Hello my dear students, welcome to Unacademy GATE English channel. And before going to start the session, I want all of you to share the session, subscribe the session. Share the session, subscribe the session, those who are coming for the first time. So before going to start, let me introduce myself. I'm Swamy. I did my MTech in Systems and Signal Processing from JNT College of Engineering in the year 2007, and since 2009 I was into this GATE coaching field, teaching my favorite subject, signals and systems and communication, throughout the country. And I have total 12 plus years of teaching experience. And first of all, we'll see what are the, nowadays I'm associated with Unacademy, and if you want to purchase any course on Unacademy, you can use my subscription KVS Live, with which you will be getting flat 10% discount on any course in Unacademy. First of all, we'll observe what are the various courses we are going to have in Unacademy. So basically, for GATE there are two types of courses, namely plus subscription and iconic subscription. So in the plus subscription, the student is exposed to live classes, crash courses, weekly tests, doubt solving sessions, and batches are conducted in both English and Hindi. If a student is not comfortable with English, he can take the batch in Hindi, and if a student is not comfortable with Hindi, he can take the batch in English from his choice of educator. Welcome Vignesh, welcome Chinna. And we have something known as rank improvement batches here. And apart from this, we have iconic batch, in which the student will be under the supervision of a experienced educator known as mentor. So here personal coach is given to every student, detailed study planner, study booster sessions are there, personalized test analysis, dedicated doubt clearing instructors are there, and preparatory study material is given to the students. Now coming to the fee structure, you may have a doubt what are the fee structure in plus subscription and iconic subscription. So if a student is planning his GATE or ESE preparation for 12 months, that is 1 year, in plus subscription it costs around 27,225 rupees only. And again, if you are going to use my code KVS Live, you are going to get flat 10% discount. Again, for the same GATE and ESE preparation, if a student is planning for 18 months, that is 1.5 year course, it costs around 34,650 only, and you can use my code KVS Live to get flat 10% discount. Again, for the same GATE and ESE course, if a student is planning for 2 years, that is 24 months, if he wants to take the subscription, it costs around 39,600 rupees only. And again, you can use my code here KVS Live to get flat 10% discount. This is about plus subscription. Then what about iconic subscription? In iconic subscription, where the student will be under the supervision of a mentor, if a student is planning for GATE or ESE preparation for 1 year, that is 12 months, it costs around 45,225 rupees only. And if you are going to use my code KVS Live, you are going to get flat 10% discount. And if a student is planning his preparation in GATE or ESE, and if he wants to take iconic subscription for 24 months, which is ideal for second year BTech students, this is ideal one, it costs around 66,600. Again you can use my code KVS Live to get flat 10% discount, whatever may be the course. So feel free to use my code KVS Live to get maximum discount, that is 10% discount. So this is about the fee structure. Now let's start the topic. Before that, how many are there? Only 4. Okay, Chinna, Vignesh. What happened to the other students, Rohit, Harika? And before going to start, let me tell you one thing, my dear student, that from tomorrow onwards, that is from tomorrow, in the morning we are going to have the class, the same signals and systems class. We are not going to have in the evening, but we are going to have in the morning, and that in the Creatrix channel, not on Unacademy GATE English channel. I think you may be aware. So in Creatrix channel we are going to have this one, right? So until the strength accumulates, only 2 persons are there, Vignesh and Chinna. We'll do one thing before going to start. Yes, let me give you a small question. Suppose if I ask you, what is the value of this integral? You know this one. What is the value of this integral? Come on. We'll start the session within a while. Let's see. Let's wait for the strength to accumulate. Evening is best, sir. Chinna. See, it is best for you, Chinna, but you might have observed nobody is turning for the class. Nobody is turning for the class. See, many free initiatives we are bringing, but nobody is turning for the class. That is the reason. 7:30 to 9 is very good time. Fine. See here, Vignesh has written pi. Vignesh, what is this one? Suppose what is this one? Area under sink T is how much? Already we discussed this one in the previous classes. 1. As sink is an even signal, can I write this as? See, this kind of questions they'll give, and you know everything, but you'll commit mistakes. Okay, Vignesh. Comfortable, Vignesh? Okay, right. So strength is not accumulating. Let's start the session. So still now, what we discussed, we were discussing the basic signals now. So what basic signals we discussed? Suppose if I recollect, unit step signal u of t we discussed. After that signum t we discussed. After that ramp signal we discussed. After that rectangular pulse we discussed. Triangular pulse we discussed, and after that impulse signal we discussed, right? Many basic signals. So the next basic signal what we are going to have is a unit doublet. Unit doublet. Generally questions from this signal will not come. See, I haven't seen questions coming from this utilizing this signal, but analysis is required, because if you are in LTI systems, in order to analyze some concepts, this basic signal analysis is required. Most of the test series also concentrate on this signal. So unit doublet signal. Unit doublet. First of all, unit doublet means it is denoted by del dash of t, d by dt of del of t. So signal which is obtained by differentiating an impulse signal, continuous time impulse signal, is known as unit doublet. Unit doublet. So how we are going to define this one? So here unit doublet signal denoted by del dash of t is defined as undefined. It is undefined at t is equal to 0 and 0 for t not equal to 0. This is one definition I can give. The other definition is del dash of t is plus infinite and minus infinite at t is equal to 0. It will attain two values, plus infinite and minus infinite at t is equal to 0, and is 0 for t not equal to 0, and integral minus infinite to infinite del dash of t dt is 0. del dash of t is 0. You have to keep this in mind. Already we have seen that if I am integrating a signal means I am calculating the area. So we can say that area under unit doublet is 0. Area under unit doublet is 0. Right? And we can say one thing that, see, impulse signal is even. Impulse signal is even signal. See, detailed analysis of even and odd signals anyway we are going to have, and we have one statement that if you differentiate an even signal, we are going to get an odd signal. If you are going to differentiate an even signal, we are going to get an odd signal. So what kind of signal is unit doublet? Even signal or odd signal? It is odd signal. Odd signal. And area under the odd signal is 0. Always remember, area under the odd signal will be 0. Area under the odd signal will be 0. Right. Now we'll see how this unit doublet came. For that, hope you are comfortable. Vignesh and Chinna, please, you must be active in the live chat. Then I can move forward. Chinna and Vignesh. Yes, okay. Observe here. Now we'll see how this unit doublet can be taken as a limiting form of other signals. See how we obtained an impulse signal. See, if you remember, impulse signal is obtained from the limiting form of various signals like step signal we took, rectangular pulse we took, triangular pulse we took, Gaussian pulse we took, exponential signal we took, many signals, sync pulse we took, sync square pulse we took, Lorentz pulse we took. Now if I take this as my triangular pulse, this is my x of t I am calling, minus tau, 0, tau, this is 1 by tau. Now what is the area under this one, x of t? Area is half base into height, it is nothing but 1. Now can I say that, observe here my dear students, can I say that limiting form, if I make this width the tau to 0 in this triangular pulse, it will become an impulse signal, right? So from here I am going to decrease the width like this. I am going to decrease the width. I am going to get some new values. Again I am considering them to be tau only. Again from this I am going to still decrease the width, my dear students. Still decrease the width. 1 by tau. So area remains the constant here. As a limiting case, if tau becomes 0, what will happen to this one? This height will become infinite. Tall narrow pulse of infinite height, but area 1. Area strength 1. So this we are calling by the name impulse signal. Impulse signal. Hope you are comfortable. Already we have seen this one, you know this, right? Now how we are going to get a unit doublet? Here unit doublet, how I defined, it is nothing but differentiation of an impulse signal. Differentiation of an impulse signal is unit doublet. Means if limiting form of this triangular pulse is impulse signal, if I take the differentiation of this one, observe here, if I take the differentiation of this triangular pulse and take the limiting form of that differentiated signal, that must be unit doublet. Again I am saying, if the limiting form of this triangular pulse is an impulse signal, and if I differentiate this triangular pulse and I get x dash of t, and if I take the limiting form of this x dash of t, I must get a unit doublet, because differentiation of impulse signal is unit doublet signal. So what happens if I differentiate, and already I told you some principles how to differentiate a signal. So discontinuities, you observe for discontinuities. So there are no discontinuities. So simply differentiation means slope calculation. So what is the slope from here to here? 1 by tau square and minus 1 by tau square. Minus 1 by tau square. So x of t differentiation is x dash of t. Now if you observe, what is the area under x dash of t? Area under x of t is 1. Area under x dash of t is how much? So this area is how much? Here area is 1 by tau. Here area is minus 1 by tau. Right? So this 1 by tau and minus 1 by tau, they get cancelled and resultant area is 0. Right? For x dash of t. Now do one thing. Take the limiting form. Take the limiting form of x dash of t. X dash of t means try to decrease the width on both the sides. So what will happen? If I try to decrease the width, height will increase. This 1 by tau square will increase. Still it decrease the width. Minus 1 by tau square. Now as a limiting case, if tau becomes 0, here what will happen? Here tau will become 0. In every case area is 0. Area is 0 here. Area is 0 here. Area will be 0 here. As tau becomes 0, see at 0 we are going to get, this is not an impulse. You should not call it as impulse, but you must call it as a spike, because impulse means area will be 1. Oh, Amit sir, I am good. So infinite at t is equal to 0, minus infinite at t is equal to 0. So this is our unit doublet. Unit doublet. These are not impulses. Remember, you can call them to be 2 spikes. 2 spikes will get. 2 spikes at t is equal to 0. We are going to get. Right? So this is about the birth of unit doublet. So unit doublet is plus infinite and minus infinite at t is equal to 0 and 0 for t not equal to 0. So in this way you are going to get unit doublet. Hope you are comfortable, my dear students. After looking at this, we'll see the properties of unit doublet. So I'll do one thing. I'll compare the properties of impulse signal with the properties of unit doublet so that you'll better understand. So impulse signal I'll take here. So here I'm getting 2 spikes, no? So that is the name doublet came. 2 spikes, one in the top, one in the down. So that's the name doublet came. Right. Impulse signal, unit doublet. If we compare, now what is the definition? What is the definition of impulse signal? Del of t is infinite at t is equal to 0 and 0 for t not equal to 0, and integral minus infinite to infinite del of t dt is 1. Doublet, del of t is infinite and minus infinite at t is equal to 0 and 0 for t not equal to 0, and integral minus infinite to infinite del dash of t. del dash of t dt is 0. Now what is the scaling property in impulse signal? Del of at is nothing but 1 by mod a del of t. 1 by mod a del of t. So what is the use of this one? If I substitute a is equal to minus 1, so del of minus t is del of t, saying that this is even. So here in unit doublet, the scaling property is del dash of at is 1 by a times, I'm not going to the proof and all, directly giving to del dash of t. So that if I substitute a is equal to minus 1, del dash of minus t is minus del dash of t, saying that this is odd signal. Right? And the scaling property, what is the scaling property? X of t into del of product property, x of t into del of t. What happens if you multiply a signal with an impulse signal? We'll get the same impulse signal with area change. Hope you are comfortable. Vignesh and Chinna. X of t into del of t is nothing but x of 0 into del of t. Now in the same way, x of t, basic knowledge on this signal is enough for you. X of t into del dash of t is nothing but x of 0 into del dash of t minus x dash of 0 into del of t. Suppose if anybody asks you or talks about unit doublet signal, you must be in a position to answer. Anyway, we are going to discuss in detail in LTI systems, because unit doublet becomes the impulse response of a differentiator, and how to calculate the impulse response and how to check the stability of differentiator we'll discuss in LTI systems. For that knowledge I am giving here all these concepts. Okay. And we have something known as sampling property or shifting property. X of t into del of t minus t naught dt is equal to x of t naught. Here del dash of t minus t naught dt is equal to minus x dash of t naught. These are the properties. One important point to be noted is just take that note. Absolute area under unit doublet is absolute area under del dash of t is infinite. Absolute area under del dash of t is infinite. Suppose if I ask you one question based on these properties, x of t is equal to e power minus t into del dash of t. Can you simplify this expression? E power minus t into del dash of t. Use the product property, you will get the answer. X of t is equal to e power minus t into del dash of t. What will come? So just now we have seen the property x of t into del dash of t is equal to x of 0 into del dash of t minus x dash of 0 into del of t, e power minus t into del dash of t. So x of 0 means what? 1 to del dash of t minus x dash of 0. So I have to differentiate this x of t and substitute 0. What will happen? It will be, I think, minus 1. minus of minus plus. Hope you are getting this answer. After this, confirm Chinna and Vignesh whether you are going to get this answer or not. Minus 2 to 2 t minus 3 into del of 2t plus 2 plus 8 cos pi t into del dash of t minus 0.5. I want the answer for this one. Both of you try. Both of you try the answer for this one. You can break the integral. You have to be very fast. Let's break the integral. Minus 2 to 2 t minus 3 into del of 2 this one. Now first integral I think you can solve. First integral from yesterday's discussion. So first of all you have to bring into a standard form. So take 2 common. If I take 2 common, it will come and will become like this. Minus 2 to 2 t minus 3 into del of t plus 1 dt plus, for this one you have to use this property, x of t into del dash of t minus t naught. What is this one? Minus x dash of t naught. So minus x dash of t naught means plus 8 to d by dt of cos pi t. Minus will come now, plus minus 8 into d by dt of cos pi t. At t naught you have to calculate. What is the in place of t naught here? 0.5. Tell me what is the answer you are going to get, my dear students. Vignesh and Chinna, what is that you are going to get? Simplify and tell me. First one is very easy. Minus 2. So this one is minus 2. The second one, tell me. I think it must be 8 pi. Minus 2 plus 8 pi must be your answer. Verify. Minus 2 plus 8 pi must be your answer, my dear students. Differentiation of cos pi t is minus sin pi t multiplied with pi. That you have to calculate t is equal to 0.5. Sin pi by t is anyway 1. Hope you are getting. Vignesh. Yes sir, 8 pi. 8 pi. Yes, yes. Minus 2 plus 8 pi will be the answer. Minus 2 plus 8 pi will be the answer. Okay, this much knowledge is enough about the unit doublet. If anybody asks you what is unit doublet means, simply say differentiation of impulse signal, and how we obtain means you try to show like this. So limiting form of this triangular pulse gives impulse means if I differentiate this triangular pulse and take the limiting form, that must give me a unit doublet which is infinite and minus infinite or undefined, because if you subtract those two, infinite and minus infinite, infinite minus infinite is undefined value. So that's what I have written here in the definition. Infinite and minus infinite, which is undefined value at t is equal to 0 and 0 for t not equal to 0, and unit doublet is odd signal. Area under the odd signal is 0. Right. This much knowledge is enough regarding this unit doublet signal. So let's proceed to the next part, that is discrete time basic signals. So discrete time basic signals. First basic signal is discrete time unit impulse. We'll see discrete time unit impulse. How you are going to define this one? Denoted by del n, defined as 1 at n is equal to 0 and 0 for n not equal to 0. So this is defined at only at n is equal to 0 of value 1, and for all other values, say for 1, 2, for all other values it is 0. It is 0. This is discrete time unit impulse. Discrete time unit impulse. What is the importance of continuous time unit impulse? Any continuous time signal can be represented in terms of impulses. In the same way, any discrete time signal, importance is any discrete time signal, can be represented in terms of impulses. My dear students, what is the expression there? In continuous, x of t is x of tau del of t minus tau d tau. Always remember, whenever you are going to have integration in continuous time, similar operation in discrete time is summation will come. So summation k varying from minus infinite to infinite, x of k del of n minus k. So we'll test with different signal afterwards, because we haven't seen the other signals, right? Okay, Khalil GT, I'm good. Right. So this is about the discrete time unit impulse, and after that let's look at the properties. So most of all the properties are similar. I can say one thing, that all the properties of discrete time unit impulse are same as continuous time unit impulse signal, but except the scaling property. What is the scaling property there? Del of 8 is 1 by mod a del of t, no? There. Here the equivalent property is del of kn. Del of kn is nothing but del of n only. Del of kn is del of n. So this is only the difference between the other properties. And your product property, it is even, and all the properties follow. What is the product property? X of n into del of n minus n naught is nothing but x of n naught into del of n minus n naught. See, if you multiply, in continuous case we have seen, if you multiply a continuous time signal with the impulse signal, we'll get the same impulse signal with area change. But here we'll get the same impulse signal in discrete time, but with value changed. That is only the difference here, right? Now the other property we can give like this. Suppose x of t into del of t minus t naught dt. If the shift t naught lies between the integration limits, simply substitute the value of shift in the given signal. Here summation k varying from minus infinite to infinite x of k into del of let me erase this one. X of n into del of n minus n naught. If the shift lies between the integration limits, simply substitute the value of shift in the given signal. This is the property. Hope you are comfortable. My dear students, suppose if I ask you what is the value of n del n, if I ask you n del n, what is your answer? What is the value of n del n? Reply, my dear students. See, n del n means use the product property. See, product property, what does it say? X of n into del of n minus n naught is nothing but x of n naught into del of n minus n naught. Or I can simplify, if I take n naught to be 0, x of n into del of n naught is 0, no? So x of 0 into del of n. So n del n. So simply substitute the value of n to be 0. So what happens if I substitute the value of n to be 0? This will become 0. So remember, n del n value is 0. N del n value is 0. Or you can visualize like this also. N means what? Suppose if I take this signal, x of n is equal to n. First signal is what? N. How we are going to draw n? For 0 0, for 1 1, for 2 2, for minus 1, simply draw the signal. For minus 1, x of n is equal to n I am drawing. For minus 2, and so on, right? So this is x of n is equal to n. Del n means it exists, n is equal to 0. Alright. Now if I multiply, and we know that multiplication of signals is nothing but multiplying at common points. What is the common portion? At 0. At 0 this value is 0, this value is 1. If I multiply, it will be 0. So in this way also you can verify. So the signal strength at n is equal to 0 is 1 or infinite. It is 1. Arey yaar, it is 1. Del of the signal strength is 1 at n is equal to 0. Signal strength is 1 at n is equal. See, we want this signal strength, its amplitude is 1 at n is equal to 0. Vignesh, its amplitude is 1 at n is equal to 0. Hope you are comfortable. Now if I write one more question like this, del of 2n plus 4 is del of n plus 2, true or false? Okay, yes, okay sir, but in continuous it is infinite. Yes, in continuous it is infinite. You are right, Vignesh. In continuous its amplitude is infinite, whereas in discrete its amplitude is 1. Yes, Vignesh. Now try to answer this one. Del of 2n plus 4 is del of n plus 2. True or false? True or false? Come on, tell me, true or false, this one. Chinna, false. Okay, Chinna. What about Vignesh, true or false? See, I gave you one property, del of kn. Del of kn is what? Del of n. Del of kn is del of n. So if I replace this k with n plus or minus n naught. So here, so if I replace this n with n plus or minus n naught, here the same thing on the right hand side also. So this k is not having any value, this scaling factor k is not having any significance, so we are discarding. In the same, now how can I write del of 2n plus 4? I can write it as del of 2 times n plus 2. What is scaling factor here? 2. So this is not having any significance, del of n plus 2. So it is true. It is true. Chinna, verify. Yes, yes. Now the next thing is, suppose if I have signal like this, suppose this is my signal, my dear students, x of n. This is a discrete time signal. Now can you represent this signal, this discrete time signal in terms of impulses? Can you represent this discrete time signal in terms of impulses? This signal is existing from minus infinite to plus infinite. How we are going to represent? So some arbitrary signal I took of my choice. I am coming from minus infinite. Now here I came. Here this is what? This is the impulse signal but advanced by 2 units. So how I can write? So value is 1 del of n plus 2. Can I write like this? Value is 1 del of n plus 2 means del of n plus 2 only. Now how I can write this impulse at minus 1 plus value is minus 2 del of n plus 1. Can I write like this? Plus here at 0, 0.5 into del of n plus 1 times del of n minus 1 plus 3 times del of n minus 2 plus so on up to infinite, or x of n is equal to, again I am coming from minus infinite. This, can I say that, observe here, can I say that this 1 is nothing but the sample value at minus 2? Yes, it is nothing but a sample value. Set of samples is nothing but discrete time signals. So I can write it as x of minus 2 into del of n plus 2 plus x of minus 1 into del of n plus 1. This 0.5 is nothing but a sample value at 0. X of 0 into del of n plus x of 1. 1 is nothing but a sample, here this 1 is nothing but sample value at 1. X of 1 times del of n minus 1. This 3 is nothing but a sample value at 2. N minus 2 plus so on up to infinite. Or by putting all these terms I can write in a single expression. summation this x of n, any arbitrary signal k varying from minus infinite to infinite, x of k into del of n minus k. Can I write like this? Because if I substitute k is equal to minus 2, I'll get this one. If I substitute k is equal to minus 1, I'll get this one. If I substitute k is equal to 0, I'll get this one. If I substitute k is equal to 1, I'll get this one. K is equal to 2, I'll get this one. Or any discrete time signal can be represented in terms of impulses by this expression. Here coefficient represents the value or area, value Vignesh, not area, not the area. In discrete it represents value only. If it is area, I would have represented with arrow, Vignesh. Instead of a dot, I would have represented with arrow. Go back to your impulse train, you will better understand. Right? So this is about impulse signal, discrete time unit impulse signal. So this is the definition. 1 at n is equal to 0 and 0 for n not equal to 0. Any discrete time signal can be represented in terms of impulses. Just now we have seen this expression, and the properties, only scaling property differs. Del of kn is del of n, and we have the product property and we have the sampling property also. Right? This much knowledge is enough on discrete time unit impulse. Next, discrete time unit step. Discrete time unit step signal. Denoted by un, defined as 1 for n greater than or equal to 0 and 0 for n less than 0. Try to draw. Okay, Vignesh, you try to draw this signal. So this is a discrete time signal, means independent variable is n. Independent variable is n. Discrete time signal, they exist only at integer values of time. So here the signal u of n is 1 for n greater than or equal to 0. 1 is 1 for n greater than or equal to 0. And it is 0 for n less than 0. U of n is 1 for n greater than or equal to 0 and 0 for n less than 0. Right? So this is discrete time unit step. Suppose from this, after defining this, if I ask you a question, can you draw the shape of the signal u of n minus 1? Can you get the shape of the signal u of n minus 1? U of n minus 1 unit step signal is 1 for n greater than or equal to 1 and 0 for n less than 1, shifted version. So u of n starts at 0, u of n minus 1 will start at what point? 1. This is what is your u of n minus 1. Hope you are comfortable with u of n and u of n minus 1. Yes, right shift. Now the next thing is, what I want is, try to subtract the bottom signal from the top signal. Subtract the bottom signal from the top signal. What happens if subtract? At 0, what is the value of the top signal? 1. At 0, what is the value of the bottom signal? 0. 1 minus 0 is 1. At 1, 1 minus 1 0, at 2 1 minus 1 0, at 3 1 minus 1 0, and so on. So we are left with this signal. But what is this signal? Discrete time unit impulse. So this is the first relationship that exists between unit step and discrete time unit step and discrete time unit impulse, that u of n minus u of n minus 1 is nothing but del of n. U of n minus u of n minus 1 is del of n. This operation is known as the first difference operation. First difference, we'll say. I can put in terms of words also, that first difference of discrete time unit step produces discrete time unit impulse. Yes, exactly. First difference of discrete time unit step produces discrete time unit impulse. Remember, this first difference operation is similar to differentiation in continuous time. It is similar to differentiation in continuous time. First difference of xn means xn minus 1. First difference of yn means yn minus 1. First difference of un means un minus 1, which is nothing but del n. Discrete time unit impulse signal. Right? Okay. Observe, my dear students. Sorry. Pages. Suppose if I take this signal, what is the signal? Del of n. If I take this signal, what is this signal? Delayed version, del of n minus 1. Suppose if I take this signal, what is this signal? Del of n minus 2, and so on. If I take this signal, what is the signal? Del of n minus 100. Now what happens if you add all these signals? What happens if you add all the signals in between? See, at 0, what is this value? 1. At 0, nothing is there, means 0. 1 plus 0 means at 0 value is 1. At 1, here nothing is there, 0. 0 plus 1 plus 0, what will come? 1 will come. At 2, 0 plus 0 plus 1, 1 will come, and so on. But what is this signal? Discrete time unit step signal. So the interesting point here is, in the first case I took u of n and I am able to get del of n by taking first difference. In the second case I took del of n now and I am able to get u of n by what? By adding like this, del of n plus del of n minus 1 plus del of n minus 2 plus so on up to infinite gives u of n. Or in short, I can write it as summation k varying from 0 to infinite del of n minus k is u of n. U of n. So this is a second relationship that exists between discrete time unit step and discrete time unit impulse. Discrete time unit step and discrete time unit impulse, which is known as summation or otherwise accumulation. Accumulation means what? Adding up, no? Summation or accumulation. Summation or accumulation. So if anybody asks you, given u of n, how you are going to get del of n means, given u of n, how you are going to get del of n means, take first difference. Given del of n, how you are going to get u of n means, take summation or accumulation. And remember, first difference is similar to differentiation in continuous time, whereas summation or accumulation is similar to integration in continuous time. This operation is similar to integration In continuous time we are concerned with differential equations. In discrete time we are concerned with difference equations. Difference equations will come. Lot of discussion is there on those equations and all. Okay. Right. Okay, my dear students. Sir, in discrete will not find area. Summation gives the area. Summation gives the area, Vignesh. In discrete will not find the area. Area, if you want, take the summation. Integration there. Yes, Manoj. I think just now you came. Now, yesterday what happened? If you observe, ut is nothing but integral minus infinite to t del of tau d tau. So how we modified? 0 to infinite del of t minus tau d tau. Both are same. We proved also. In discrete also we have a similar kind of relation. Summation k varying from minus infinite to n del of k. This is nothing but summation k varying from 0 to infinite del of n minus k. So your del of n minus k, whatever the relation we got here, summation k varying from 0 to infinite del of n minus k, can be written in this fashion also. In exams, if they give this one or this one, both are same. Yesterday I proved for this one. The same thing holds here also in discrete. Observe here, minus infinite to t, minus infinite to n, del of tau d tau, del of k here, discrete. So this can be written as 0 to infinite del of t minus tau d tau. The same way it can be written as summation k varying from 0 to infinite del of n minus k. If you want the proof, you can try. You people can try the proof also. Same proof as I did yesterday, dear students. Right. Now, if you remember, while discussing the continuous time, suppose before performing the transformations of the independent variable, I want to ask you something. That is, u of n plus u of minus n minus 1 is 1. True or false? U of n plus u of minus n is 1 plus del n. True or false? Sir, what is the difference between evening classes and morning classes? See, Manoj Kumar Reddy, the idea is in the evening classes we want to take more initiatives in this Unacademy GATE English channel, but the students coming are very less number of students are turning. So the team has planned to launch this session in the morning class at 7:30 AM on Creatrix channel. From every basic, from the first basics, everything will be repeated because we are expecting more crowd there. If you observe, only 3 or 4 persons today came, and nobody discusses these kind of detailed analysis on each and every basics in the offline. That you people must understand. First one, Manoj, first one is true, second one is false, Manoj. Okay, what about Vignesh and the other guys? So let's draw. Un means, anyway, you know how to draw u minus n minus 1. U minus n minus 1. This is the transformation involving Vignesh. Sir, it will be in English. Yes, it will be in English only. It will be in English only, my dear students. See, the actual session starts from 6 a.m. 6 a.m. to 7:30 a.m. Communication subject is there by Kanakai Naidu sir, and from 7:30 to 9 I will be taking. You can happily attend and inform your friends also. So u of minus n minus 1, how you are going to get this one? This is a transformation involving first shift, then shifting as well as scaling. So let's go for first shift then scale. U of n, go to u of n minus 1. So let this be some y of n, calculate y of minus n. U of n means exists from what value to what value? 0 to infinite. U of n minus 1 means 1 to infinite. Y of n exists from 1 to infinite. Y of minus 1 exists from y of minus n, minus infinite to minus 1. So y of minus n exists from minus infinite to minus 1, but with a value of 1, because unit step signal, no? So let's add. So u of n. If you people come more in number, then we'll have lot of initiatives. But as everything is provided free for you, you're not turning. This is u of n. Now u of minus n minus 1. And most of the students are saying that, sir, we don't have time. Nobody is having time. You have to pull. Nobody in this world is having time. You have to pull. So u of minus n minus 1 means, okay, Sai Pavan. Now what we have to do? Simply we have to add these two signals. Add. So what happens if I add? At 0, this value is 1, this value is 0. 1, nothing is there means 0. 1 plus 0 is 1. At 1 it is 1. At 2 it is 1. At 3 it is 1, and so on. At minus 1 it is 1. At minus 2 it is 1, and so on. This is 1 in discrete, no? This is 1 in discrete. Yes, it is true. It is true. So this is a signal called 1 in discrete. In continuous also we have seen ut plus u minus t is 1 in continuous. So in discrete, un plus u minus n minus 1 is 1. Un plus u minus n minus 1 is 1. You have to remember this. Remember this. Now let's look at the next one. U of n plus u of minus n is 1 plus del n. U of n one, two, three. U of n. U of minus n. U of minus n means simply time reverse version. Mirror image along vertical axis, my dear students. This is u of minus n. What happens if I add? At 0, 1 plus 1 is 2. At 1, see, from 1 it is the topmost signal, from 1 is 1, and from the bottommost signal from 1 it is 0. So this kind of signal. This kind of signal. So this is your u of n plus u of minus n. Can I write it as 1 plus del n? So what happens if I add del n to this one? What happens if I add a del n? Del n means value is 1 and n is equal to 0. So if I add this signal, this signal and this signal, I'm going to get this signal only. Observe here, if I add this signal 1 and this del n, I'm going to get this one only. So it is also true. Manoj, you are wrong, man. It is true. So both are true. This is true. This is true. Both are true. Hope you are comfortable. Simply draw the signals. I thought step instead of impulse. Yes. Manoj, these kind of mistakes only you commit in the exam. Please don't commit those kind of exams. One mark makes much difference in the exam, right? So both are true. So time is 8:07. Let's take one more small case here. And what happens if I scale? What happens if I scale a unit step signal? Means scaling in discrete time means decimation and interpolation will come now. So before going to see those, I want the shape of the signal. Draw. Draw the signal x of n is equal to u of n minus 1 minus u of minus n minus 1. All of you try to draw this one. U of n minus 1 minus u of minus n minus 1. Very simple. I can rearrange this as u of n minus 1 plus minus of u of minus n minus 1. This exists from 1 to infinite with a value of 1. This exists from u of minus n minus 1 means minus infinite to minus 1 with a value of minus 1. Try to add. So what happens if I add? I can show like this. U of n minus 1 this is u of n minus 1 and what is u of minus u of minus n minus 1? Already we are having u of minus n minus 1 na? Already we are having u of minus n minus 1. Take the amplitude reversal, mirror image along horizontal axis. So what will happen? Now my dear students, can you tell me what is this signal? What is this signal? Yes Manoj, you are right. Discrete signum of n. So signum of n is nothing but, how you are going to define? Can I define like this? 1 for n greater than 0, 0 at n is equal to 0 and minus 1 for n less than 0. Can I define like this? Or signum of n is 1, 0, minus 1. N greater than or equal to 1, 0 at n is equal to 0, or n less than or equal to minus 1. Come on my dear students, both are right na? Both are right. Now can you give me any other representation for signum in terms of unit steps? This one signum, I said this is signum of n. Okay, signum of n, this is one expression. Now can you give me one more expression in terms of unit steps only? can you give one more expression in terms of unit steps only? What happens if I draw x of n is equal to u of n minus u of minus n? What happens if I draw u of n minus u of minus n? Is it same as signum? Let me confirm my dear students. Manoj, Vignesh, Chinna, can you confirm? So this is one more representation. You can verify whether you are going to get this. This is also signum of n. This is also signum of n. You can verify. Right. Two u of n minus 1 minus del n. Yes, Manoj, you can have many more. 2 u of n minus 1 minus del of n. You might be getting, Manoj, right? So this is about the unit step signal. Students, we have to look at the transformations of the independent variable. What happens if I scale and all unit step signal? That we'll discuss in the next class, but the next class will be in the creatrix channel, my dear students. And after that, in discrete, we are left with a ramp signal. We have to discuss ramp in discrete and the problems based on the ramp. So now I'll give you one question here. I'll give you one question. So all of you try to answer this question. Consider the signal x of n is equal to only 10 seconds time for this one. 1 minus summation k is equal to 3 to infinite del of n minus 1 minus k. Determine the values of m and n naught so that x of n may be try to get the answers. What is the value of m and what is the value of n naught, my dear students? Only 10 seconds time. You know everything here. I want m, I want n naught. What is m, what is n naught? M is minus 1 and n naught is 3. Manoj Kumar ready? M is, Manoj Kumar said m is minus 1, n naught is 3. Manoj, I am writing. Manoj answer. Okay. Any more answers? Vignesh and Chinna, you two people are there. Your answer is locked, Manoj. Your answer is locked. Any more answers? Or you people also support this answer? Sir, no. Your answer is locked, man. This seems to be correct only. M is minus 1. You are changing the answer. Manoj, M is minus 1 and not is minus 3. Minus 3. Okay. Let's verify. So, simple. What is this? Try to understand the problem. X of n involves subtraction of two signals. A signal called summation k is equal to 3 to infinite del of n minus 1 minus k is subtracted from the signal called 1. After subtracting, is getting a resulting signal. That resulting signal is expressing in terms of unit steps. In that process, is asking us to calculate the values of m and n naught. Now, how you are going to draw 1 in discrete? Let's draw 1 in discrete like this, na? In different styles we can solve this problem, but my style is this one. And what is the other signal? This is x of n. Summation k is equal to 3 to infinite del of n minus 1 minus k. Do one thing, give different values of k. What happens if I substitute k is equal to 3, del of n minus 4 plus del k is equal to 4, del of n minus 5, del of n minus 6, and so on. Now try to subtract the bottom signal from the top signal. If you observe, the top signal is existing from minus infinite to plus infinite, is a DC signal, constant signal, whereas the bottom signal is existing from 4 to infinite, and subtraction is involved. Now from minus infinite to 3, what is the amplitude of the top signal? 1. And from minus infinite to 3, what is the amplitude of the bottom signal? 0. 1 minus 0 is 1. And after 3, from 4, amplitude of the top signal is 1, amplitude of the bottom signal is also 1. 1 minus 1 is 0. So the resulting signal exists from minus infinite to 3, but with a value of 1. So this is the resulting signal x of n. Now the question is, can you express this signal in terms of unit steps? Yes, we can represent. So can I write it as u of, observe here my student, if you have any doubt, u of minus n minus 1, come here, u of minus n minus 1 means exists from minus infinite to minus 1. So if it exists from up to 3 means u of minus n plus 3. So this is u of minus infinite to plus 3, minus n plus 3. Now compare with u of mn minus n naught. What is the in place of, if you compare, what is the in place of m? Minus 1. What is the in place of n naught? Minus 3. So minus 1 minus 3, Manoj, your answer is correct answer. Correct answer. M is minus 1 and n naught is minus 3. This is the answer. Right? So the remaining operations we'll see in the next class, my dear students. The scaling of continuous time signal and ramp signal, and scaling of a discrete time ramp, and various problems. Many problems are there, many problems are there, that we'll discuss in the next class, but on Creatrix YouTube channel. And I want a huge crowd tomorrow in the morning. So tomorrow, let me tell you, tomorrow morning your class starts at 7:30 AM on the Creatrix, and the name of the batch is Impulse. The name of the batch is Impulse. Right, my dear students? Okay, so that's all for this class, and you can follow me on Unacademy at unacademy.com at Swamy. My name is Swamy. Right, sir, I miss you in WhatsApp. I messaged. Okay, I'll check, Chinna. I'll give you a reply. Regarding the addition and subtraction of signals, now we'll plan, Chinna. I'll let you know after the class. And please subscribe to this channel. This is not GATE Telugu no more. This is GATE English channel. Subscribe. And let me tell you the available channels in Unacademy. So Creatrix GATE ECEEIN, Unacademy GATE MEPIXE, Unacademy GATE Civil and Chemical, Unacademy Computer Science, Unacademy GATE Questions, Unacademy Computer Science by Ravindra Babu Raola, this is Computer Science, Unacademy GATE English, this is our channel, Electrical Junction, Apti Express, these are the channels available. And finally, thank you for attending, and please, will this be continued? This won't be continued, Manoj. Basics of, I think from the basics we are going to start. Anyway, you can check in the morning. you can check in the morning at 7:30 a.m. So I'm expecting a huge crowd tomorrow. Okay, inform your friends also. So thank you, my dear students.